Welcome to the lesson on the human eye. At the end of the lesson, we will be able to explain the structure of human eye, explain power of accommodation, describe defects of vision and their correction. With smell, we can identify a flower. But to know the color of the flower, we need our eyes. Therefore, the human eye is the most significant organ as it enables us to see the beautiful and colorful world around us. Now let's look at the structure of human eye. The human eye is like a camera. Its lens system forms an image on a light-sensitive screen called the retina. Eye consists of cornea. Light enters the eye through a thin membrane called cornea. It forms transparent bulge on the front surface of eyeball. Most of the refraction for the light rays entering the eye occurs at the outer surface of the cornea. The crystalline lens provides the finer adjustment of focal length required to focus objects at different distance on the retina. It is a double convex lens situated behind the iris. It is composed of a fibrous jelly-like material. The lens is held in position by suspensory ligaments connected to the ciliary muscles. By contracting or relaxing, the ciliary muscles can change the shape or curvature of the eye lens and hence change its focal length. Behind the cornea, there is an opaque circular diaphragm called iris. The color of the iris determines the color of the eyes of a person. The iris has a central hole called the pupil. Due to its muscular action, the iris controls the size of the pupil and hence regulates the amount of light entering the eye. In bright light, the pupil becomes small. In dim light, the pupil opens up completely through the relaxation of the iris. The eye lens forms an inverted real image of object on an important structure called retina. It is a delicate inner membrane on the back wall of the eyeball. It contains light-sensitive cells called rods and cones. Rods are sensitive to intensity of light, while cones are sensitive to colors. These cells change light energy into electrical signals which are sent to the brain via the optic nerves. The brain interprets these signals and enables us to detect objects. In the region where the optic nerve enters the eyeball, there are rods and cones. This region is totally insensitive to light and is called blind spot. Yellow spot has maximum concentration of light-sensitive cells. It is situated in the center of the retina. Accommodation is the ability or property of the eye lens due to which it can change its curvature or focal length so that images of objects at various distances can be formed on the same retina. The focal length of the eye lens is automatically changed with the help of ciliary muscles. When the ciliary muscles are completely relaxed, the eye lens is thin and its focal length is maximum. The rays coming from the distant object are parallel to each other and they are focused at the retina. When we look at a nearly object, the ciliary muscles contract, the eye lens bulges out and becomes thick and its focal length is reduced. This focuses the light from the nearby object on the retina. The smallest distance at which eye can see objects clearly without strain is called near point of eye. It is about 25 centimeters for a normal eye. The farthest point from the eye at which an object can be seen clearly by the eye is called the far point of the eye. For a normal eye, the far point is at infinity. This is Ravi's grandmother. She is suffering from cataract. In old age, the crystalline lens of some people becomes hazy or even opaque due to the development of membrane over it. This condition is called cataract. This causes a decrease or loss of vision of the eye. This vision can be restored after getting cataract surgery done. Sometimes a human eye gradually loses its power of accommodation. Then we cannot see objects clearly. Our vision becomes defective. There are mainly three common defects of vision: myopia or nearsightedness, hypermetropia or farsightedness, and presbyopia. Myopia or short-sightedness is a vision defect in which a person can see nearby objects clearly, but cannot see the distant objects clearly beyond a certain point. This defect is common among children. This defect arises due to these reasons. The eyeball gets elongated along its axis so that the distance between the eye lens and the retina becomes larger. The focal length of the eye lens becomes too short due to the excessive curvature of cornea. As a result, the parallel rays coming from a distant object do not meet at the retina, but at a point in front of the retina. The distant object is not seen clearly. The object has to be shifted closer to the eye to a point F to focus it on the retina. Thus, the far point of a myopic eye is not at infinity, but only a few meters from the eye. A myopic eye is corrected by using a concave lens of focal length equal to the distance of the far point F from the eye. This lens diverges the parallel rays from distant object as if they are coming from the far point F. Finally, the eye lens forms a clear image at the retina. Hypermetropia or farsightedness is a vision defect in which a person can see distant objects clearly, but cannot see nearby objects distinctly. This defect is caused due to either of these reasons. Focal length of eye lens is too large, resulting in the low converging power of the eye lens, or the eyeball becomes too small along its axis so that the distance between the eye lens and the retina is reduced. As a result of the above causes, the rays coming from an object placed at normal near point, that is 25 centimeters from the eye, meet at a point behind the retina. Hence, the object is not seen clearly. To focus the rays again on the retina, the object has to be moved away from the eyes to a distance greater than 25 centimeters. Thus, the near point of the eye is not at 25 centimeters, but it shifts to N' at a distance greater than 25 centimeters from the eyes. A hypermetropic eye is corrected by using a convex lens of suitable length. This lens diverges the rays such that The rays coming from normal near point N appear to come after refraction from near point N dash of the defected eye. The virtual image of the object placed at N is formed at N dash. Then, the eye lens forms a clear image at retina. This defect is similar to hypermetropia. A person cannot see nearby objects distinctly, but can see distant objects without any difficulty. This defect differs from hypermetropia in the cause by which it is produced. Some person, due to aging, lose power of accommodation of eye. This defect is caused due to gradual weakening of ciliary muscles and diminishing flexibility of eye lens. Sometimes, persons may suffer from both myopia and hypermetropia. Such people require bifocal lenses. Bifocal lenses consist of both concave and convex lenses. At the end of the lesson, we are able to explain the structure of human eye, explain power of accommodation, describe defects of vision and their correction,